So for this video, we're going to talk about 2D kinematics again, acceleration in the x and y directions, and then we'll go over example problem number 20. So for this problem, what you need to know is 2D kinematics equations, which are x equals x naught plus initial velocity of x times t plus 1/2 acceleration x times t squared. And for this equation and the next one too, just remember that you can swap in x for y and vice versa. So the next equation is velocity of x at a certain time equals initial velocity of x plus acceleration of x times t. So now what we're going to remember in a 2D kinematics situation, I'll just draw a little diagram. So right here you'll see the path it takes, assuming it's launched and ended, like hits the ground from the same height, is going to be the same no matter what the initial velocity is. So the velocity here or at the beginning will be the same velocity at the end. At the top, of course, it's going to be 0, which is at maximum height. So now, one thing I want to remind you is that like the velocities are something different. So x velocity always remains constant. What that means is that there's no x acceleration in the x direction. So a is going to be equal to 0, which means velocity in the x direction is just constant. Meanwhile, in the y direction, as long as the projectile motion is in the close proximity to the Earth's surface, which is usually assumed in these types of problems, acceleration is usually be downward, so negative 9.1, just because of gravity, which we usually approximate as 10 instead of 9.81. So now we'll go to the practice problem, or problem number 20. I'll read it out real quick and show you. A student throws a metal sphere which follows the path shown above. If air resistance is negligible, which of the following is a correct relationship between the magnitude of the accelerations, acceleration at point K, acceleration at point L, and acceleration at point M at the 3 points shown? So this problem is actually a trick question because no matter where it is, the acceleration is going to be the same. So we already know, just based off that it's A. Because, remember, acceleration in the x direction is always 0. Because x velocity is always constant. And acceleration in the y direction is always the force of gravity, which is negative 9.81, or approximated to negative 10 meters per second squared. So what that's going to mean is that each point, no matter where it is along the projectile motion path, it's always going to have the same acceleration. So we know that no acceleration will be bigger at certain points, and they're all going to be equal, as we can see. So answer choice A is going to be the correct choice. And they talk about the magnitudes of the accelerations. So the magnitude is the same because acceleration is 0 for x and negative 9.81 for y. So if we take the acceleration, which is x acceleration squared plus y acceleration squared, we're just going to get the magnitude of 9.81, which we approximate to 10. And again, same for all the points. So A is going to be our correct answer choice.